On a modern assembly line, the relentless pace of movement and processing gives the immediate impression of maximum efficiency. Robotic arms pivot, materials glide down conveyors, and the facility hums with continuous activity. But high utilization is not synonymous with value generation. A factory floor running at full speed often masks severe systemic failures. Every operation has a finite capacity. It's defined by available time, the movement of material, physical effort, and human potential. That capacity is easily hijacked. It gets consumed by invisible activities that absorb resources but add zero value to the final product, activities the customer does not require and will not pay for. To diagnose these hidden drains on capacity, industrial engineers utilize the 8 wastes framework, known by the acronym DOWNTIME. This serves as a forensic diagnostic tool for systemic redesign. We are going to use these 8 categories as a lens to deconstruct a standard process. We will expose the hidden inefficiencies inside an operation and connect raw observation to targeted structural changes. Relying strictly on top-line operational metrics often creates an illusion of productivity. It allows an organization to hide failure behind constant motion. To find friction points, we map the physical place of work, the gemba. Nodes represent workstations, and vector lines trace the flow of work-in-progress materials. The first waste is defects, errors, and rework. Every error mandates root cause analysis to prevent line breakdown. Defects cause a cascading effect. A rework loop stalls downstream stations, injecting severe delays and direct risk to the customer. The next physical waste is inventory. Excess work in progress or finished goods act as dense physical buffers, choking the pathways. This exposes a critical professional trap. Management often deliberately deploys excess stock as a shield to hide underlying line imbalances and weak material flow. Warning tone. Aggressively reducing these inventory buffers without first fixing the process instability that necessitated them will immediately halt production. Even when material flows freely, the physical movement required to process it is not inherently valuable. We categorize the unnecessary movement of material or information between different locations as transportation waste. Pushing goods across a facility adds handling time and damage risk without advancing the product to specification. This differs from motion waste, the unnecessary physical movement by operators within a localized workstation, like reaching, bending, and searching. Over a single shift, excessive localized motion creates immense operator fatigue. That physical strain actively degrades long-term system output. Left unchecked, these physical frictions force a system to expend the majority of its energy merely sustaining its own operations, rather than producing actual value. Process failure is equally rooted in temporal logic. This Gantt chart maps those same process steps horizontally against time, shifting focus to the duration of work. Looking at temporal logic exposes overproduction, making more, earlier, or faster than the customer requires. This is perhaps the most deceptive waste in an operation, because it frequently masquerades as efficiency, hiding behind aggressive organizational utilization goals. Pushing a machine to maximum output when downstream stations cannot handle the volume destroys predictable lead times. Those bottlenecks inevitably create waiting. This is the idle time between steps, where capacity sits entirely unused. This dead space typically accumulates at systemic cue points: physical handoffs, manager approvals, machine setups, maintenance breakdowns, and batch logic processing. Categorizing idle time as waiting without investigating the root cause is a mistake. Often, operators are forced to wait because of inflexible batch logic. Finally, we see extra processing. This means executing more work than the core customer specification demands. In practice, this looks like duplicate inspections, redundant management approvals, unnecessary aesthetic polishing on internal components, or heavy over-documentation. These temporal wastes are dangerous because they are formalized as standard operating procedure. The system masks gross inefficiency under the guise of thorough diligence. After tracking spatial friction and temporal bottlenecks, a thorough forensic audit must pivot to the invisible networks governing the system. This information flow layer visualizes a critical failure point. Organizations routinely hyper-focus on visible material flow while completely missing the parallel reality of data waste. A bottlenecked digital approval gate generates massive delays on the floor. To a manager strictly tracking physical goods, these digital stalls appear completely invisible. The final waste component resides in the human element forced to navigate these rigidly designed systems. Non-utilized talent is the failure to leverage the direct knowledge and problem-solving capability of the people actually executing the work. Continuous improvement stalls the moment the operators closest to the gemba are excluded from process redesign. They know where the time is lost. Too often, analysts ignore non-utilized talent simply because human potential is harder to quantify on a spreadsheet than physical scrap rates or transport distances. A system reaches true optimization only when its invisible data architecture and the intellectual capital of its workforce are perfectly aligned with its material flow. Applying the downtime protocol requires a strict methodology. The first mandatory step is direct observation at the gemba, rejecting abstract reports in favor of physical reality. Second, investigators map the exact flow, isolating the precise cue points where time and material stagnate. Third, they track hard metrics, measuring the specific durations of rework loops, wait times, and transportation distances. Fourth, they ruthlessly compare the actual work content being performed on the floor against what the customer explicitly requested and agreed to pay for. When organizations implement this framework poorly, it degrades into a passive, unactionable checklist, a theoretical exercise disconnected from daily operations. Used correctly, it acts as a prioritization lens. It forces cross-functional teams to confront exactly where value is actively bleeding out of their operation. Identifying a specific category of waste provides zero utility if it does not trigger action. The ultimate measure of operational excellence is connecting every single identified waste to a tangible root cause process redesign. By mastering the 8 wastes, practitioners stop treating localized symptoms and start engineering highly stable, value-driven systems.